help us know we're in the ileum, and duodenal patches help us know we're in the duodenum. How do we know when we're in the jejunum?
There's neither.
Neither, or neither. Sure. Okay, so that's how we know this is small intestine, not stomach. You know, you may think, oh, maybe these are what in the stomach?
What is one in the stomach?
What in the stomach might look kind of
Rugae?
like this? Rugae, yeah, because the stomach has a wrinkled lining, but you know, these villi are tiny, tiny. They're not rugae. So, how else will you know it's not the stomach?
Because of the layers.
Because of the layers of
Mucosa, submucosa, and the muscle, the
Muscle
muscle externa.
muscularis externa and the serosa, but stomach has all those.
Has vein.
No. Here in the muscularis externa, what do we see?
2 layers of muscle.
2 layers of muscle.
That's right.
Someone asked,
The
what is
muscle
this
has-
model?
Stomach has 3.
1, 2, 3. This is a stomach lining model. It still has a mucosa. I know where the mucosa layer starts and ends because I can, you know, envision this as the lumen, the inside of the chamber. But also I can find the muscularis mucosae. The mucosa ends with a thin muscular layer to help kind of nudge stuff that might get, you know, stuck or trapped. It's just a small muscular movement. So I find that, now I know that all that's mucosa. That must make this submucosa. Then this is pretty clearly muscular tissue, and that just leaves the serosa. So identifying the 4 layers should be pretty straightforward, and you'll probably get a question about it. You know how it goes, name the layer, what organ is this, name the specific thing. You know, lacteal, or Peyer's patch, or muscularis mucosa, or the stomach has a few things, like these are gastric pits, and these are gastric glands. Remember, a gland is just a bunch of cells. They're all making something, and then they squirt it into a little tube, and then squirt it to where it's going to go. So you can see how there's yellow and purple and light blue cells, because we said the stomach's making mucus, it's making HCl, it's making pepsin, start breaking down proteins. So that's why all those different colored cells are in there. But at the end of the day, all they're doing is squirting that up out of the gland into these little pits, into the lining of the stomach. I think that's really the only special things on this model are just the glands and the pits.
And the 3 muscles are longitudinal, circular, and oblique.
Correct. So which one do you think is oblique?
The small
This one,
muscular
yeah.
one,
Because you can see these are cut, they're coming right towards you and got cut, and these are going longitudinally or this way, and these are at a diagonal, the oblique layer. Yeah. So this one has a lacteal. So what's the function of a lacteal?
Absorb, sucking fat.
Yeah. So fat, we can use bile salts to what-y-what-y it, emulsify the fats, start to kind of like, you know, make the oil that's floating on the water. You need to start to make that break apart a little bit. So that's what bile salts help do. But even when you make them into smaller and smaller fat globs, they're still not tiny enough to go into a cell. That's what like an amino acid can do. After you take a long protein, break it down into individual amino acids, that's tiny. That'll go right into a cell. But a fat glob, it can't go into the cells, but it can get sucked into a lacteal. Anything we missed on these models? That's the bulk of it, at least.